Have you ever wondered what work truly means in science? Today, we will explore the concepts of work, energy, and power. We will define each, see real-world examples, and solve simple problems. First, let's understand work. In physics, work is done when a force causes an object to move some distance. Imagine pushing a heavy box. If the box moves, you are doing work. Work equals force multiplied by the distance moved in the direction of the force. Its unit is the joule, which is 1 Newton meter. If you push a wall, even with great effort, no work is done because the wall does not move. For example, lifting a 10 Newton book by 1 meter means you do 10 joules of work. Now, consider pushing a toy car with 5 newtons of force over 2 meters. The work done is 5 newtons times 2 meters, which equals 10 joules. Next, we define energy as the capacity or ability to do work. Energy can exist in different forms, like heat, light, sound, or mechanical energy. We will focus on mechanical energy, which has two main types, kinetic and potential. Kinetic energy is the energy an object possesses due to its motion. A moving car, a flying bird, or a running child all have kinetic energy. The faster an object moves, the more kinetic energy it has. Its formula is 1/2 times mass times velocity squared. So, a 2 kilogram ball moving at 3 meters per second has kinetic energy of 1/2 times 2 kilograms times 3 meters per second squared, equaling 9 joules. Potential energy is the energy an object possesses due to its position or state. Think of a book held high above the floor. It has gravitational potential energy. This energy is stored, ready to be converted into kinetic energy if the book falls. Gravitational potential energy equals mass times gravity times height. If you lift a 5 kilogram object 2 meters high, it gains 5 kilograms times 9.8 meters per second squared times 2 meters of potential energy. Roughly 98 joules. Consider a stretched rubber band or a compressed spring. They also store potential energy. The energy stored in the rubber band or spring is elastic potential energy. Finally, let's explore power, which tells us how fast work is done or energy is transferred. Power is the rate at which work is done. It is calculated as work divided by time, or energy transferred divided by time. The unit of power is the watt, which is 1 joule per second. Imagine two people lifting the same 100 joule box. If one person lifts it in 10 seconds, their power is 100 joules divided by 10 seconds, which is 10 watts. If the second person lifts the same box in just 5 seconds, they exert 100 joules divided by 5 seconds, equaling 20 watts. The second person is more powerful because they did the same work in less time. Let's tie these concepts together with an example. A student lifts a 2 kilogram textbook 1 meter high from the floor. The work done by the student is the force needed to lift it. Roughly 20 newtons times 1 meter, which is 20 joules. At that height, the book now has 20 joules of potential energy. If the student lifts it in 2 seconds, their power output is 20 joules divided by 2 seconds, or 10 watts. If the student then drops the book, its potential energy converts into kinetic energy as it falls. Just before it hits the floor, all 20 joules of potential energy will have become kinetic energy. You can calculate its speed just before impact using the kinetic energy formula. Think about how these principles apply to simple tasks you do every day, like walking upstairs. We've defined work as force over a distance, energy as the ability to do work, and power as the rate of doing work. You now understand kinetic energy from motion and potential energy from position. Linking back to our opening idea of everyday work. Keep observing the world. You will see work, energy, and power in action everywhere around you. Generate your own educational videos for free at eduvids.vercel.app.